Hi everyone, welcome back to Abrar channel. Today we are going to discuss about SPC, Statistic Process Control, and we are discussing the series called IATF, International Automotive Task Force 16949, and is the automotive series, right? In the automotive series, in the 5 automotive core tool formed by AIAG, Automotive Industry Action Group, 5 core tools you all know. Number 1 APQP, number 2 PPAP, number 3 FMEA, number 4, that's what we are going to discuss today, SPC, number 5, which we have already dwelled a video, that is called MSA. So SPC, if you take it, and this is SPC part 1, and I will also be making part 2 also as well, which will to do with the process capability. Let's hop on to this subject. So SPC, as I was briefing about, while I was explaining about MSA, I was telling that there is a very important thing is depend upon the type of data, your tool will vary. For example, just to recap what we discuss in MSA. In MSA what we discuss, if your data is variable data, you can use GRR. If your data is the discrete data or attribute data, you can use attribute agreement analysis. Exactly in the same way, if your data is a variable data, then you have a 3 control chart. One is called IMR, one is called IMR mean individual moving range chart. The next one is X bar R chart. X bar meaning like mean range chart, mean range chart, and X bar S chart, this means standard deviation. This is to do with the variable. When you have a variable data, measurable data, which is coming from the machines, your temperature you're measuring it, and you are measuring that the bowler, how the bowler is bowling the ball, what is the the length the bowler is bowling it, what is the speed the bowler, it's all variable, right? So this is to do with the variable, right? And then discrete is the another side. The discrete is attribute where you can count or classify, right? For example, you have 2 things, defect and defective. Defects is one product, one failed product can have a multiple defect. For example, marker is not working, right? This marker is not working, defective is 1, but defect can be more, right? Maybe the ink would have got completely dried off, number 1. Number 2, the nib would have got broken, number 2. And number 3, the printing, the painting, everything would have got removed off. All these are factors. That is, in this case, 3 defects, 1 defective. Exactly in the same thing, when you are dealing with the defects, right, then you have 2 choice, either to go with the C chart and U chart. If you are dealing with the defective, right, if you have a defective, then you can use P chart, that is proportion chart, or NP chart, right? So let's come back to this. These are 7 control charts are available in SPC. How many control charts? 7 control charts are available in SPC. Okay, and then you may ask me the question that what about the run chart? Does it not come under the control chart? No. The run chart, the unique difference between run chart also used for variable data. Only the subtle difference is every control chart do carry the limits. For example, UCL and LCL, for example, upper control limit, lower control limit, right? That's what all the control chart. But run chart will have, for example, typically if you look at here, run chart will be like this. One is straight line and then this is the one, right? This is the run chart, right? But whereas any control chart, all the control chart will have a center line, will have upper control, will have a lower control. Let's dig it more into variable chart. In variable chart, IMR chart is used when you have only one set of data. For example, you are measuring a performance of a one machine, you are measuring the cycle time of a one thing, one person or one process. All these, when you have a subgroup is 1, you can use IMR chart, right? So now you have a multiple thing. For example, there are 5 machines are there, or 5 appraisers are there, or 5 processes are there. You wanted to take a mean of all the things, then you have a choice called X bar R chart. X bar meaning like mean, it takes the entire average. For example, the average of average, that is called X bar, and then range. Range to do with the precision, right? How precisely. Range formula you already know. Maximum minus minimum. For example, let's say the first the first output has been there as example. The first output is 18 units are there. The second output is 22 units are there. So the range is 22 minus 18. 4 is the range, right? Exactly the same thing, and then it gives the R bar also as well. The average of the entire range also it gives. So that is called X bar R chart. X bar S chart is not widely used. Okay, even you have a multiple things, more than one, you can definitely use X bar R chart itself. You don't need to use X bar S chart. Why? Simply range is easy to interpret. For example, maximum minus minimum is range, whereas the X bar S chart is a difficult one. Why difficult? Standard deviation is difficult to interpret it. So therefore, in variable there are 3 chart: IMR chart, X bar R chart, X bar S chart, but predominantly IMR chart and X bar chart is being used. Let's hop on to the defect one, the discrete one. In discrete you have C chart and U chart. So we are talking about defects, right? It just simply count. That's all. Nothing. It will not do anything. It will simply count. For example, you have a quantity. Let's say this is fixed and variable. There is something called fixed and variable. And fixed sample you have. Let's say you are getting 100 samples, and then you are measuring like 2 defects are there, and then 4 defects are there. Simply plots up this one, and it gives you C bar, and then it gives you C bar, that is 1, and then UCL and LCL it gives it. Exactly the same thing. U per unit, how many occurrences per unit. For example, as I am going back to my previous example, this is one marker has got 3 defects, right? That means, so I will take that entire population, and then I will take that one. In this particular, assume that it is, that means 0.33 defect per unit, right? So 1 divided by 3 defects I have, right? 0.33. So that's what unit, occurrences per unit, count occurrences per unit. This is U chart. And then P chart and NP chart, but predominantly P chart you can use it. Whether you have fixed sample, you can use a P chart. The only difference is P chart it will give you like this, or if you have that the variable sample, it will give like this. But depending upon your denominator and numerator, it will give like this. So both charts can be used. So P chart is a proportion chart. It gives you a proportion. For example, let's say you have an 100 quantity, and then 2 quantities fail. So rejection rate is 2, right? It will give you the value like 0.2. And it plots up this one, it gives you P bar and all that. So this is the entire explanation of control chart. Let's talk about all these. There is something called limit. For everything there is a formula to it, how to calculate the limit. So this is not coming from the specification, this is coming from a process. For example, P bar, and you wanted to calculate that UCL of P bar, right? You already know the formula. P bar like plus, you can put 3 root of P 1 minus P divided by N, right? That is the P bar. Like this, for all these things there is a formula being associated. I have already done in Excel, in many tab I have already done it. You can catch up to know how to calculate the limit. So therefore, so all to do with the SPC has got 7 chart, and all chart carry the limits. That limits is being calculated based on your samples, based on your N value, based on your limits, based on, for example, let's say you wanted to talk about IMR chart, again X bar, and then you have A2 into R. So what is the amount of data you have and all that, all the limits are calculated. It is not coming from the specification, it is coming from the process based on the constant value. The many tab does calculate this one, and you can do it in the Excel also as well. So this is all about the SPC. I hope you enjoy this video. Please do like, share, subscribe to the channel. You have a wonderful day ahead.